Okay, here we go. We are going to finish up our segment on the Pythagorean theorem, and then we're going to jump into other types of triangles. And instead of looking at their sides, we're going to look at their angles. So I hope you're ready. I hope you have your notebook with you. And away we go. All right, so first thing you can write down is apply the Pythagorean theorem in the coordinate plane. This is uh for September 29th to October something, October 3rd, I think. We'll go with that. And we are going to cover module 11, section 4, as well as module 4, section 1 at the end of this video, hopefully. Okay, so let's look at what it says in Step It Out. To find the distance between 2 points in the coordinate system on a coordinate plane, draw a right triangle using the horizontal and vertical lines of the grid, with the given points as endpoints of the hypotenuse. Use the Pythagorean theorem to find the distance between the points. All right, this is going to make more sense when we do it. So they have already given us a grid here, and they want us to find the distance between 9, 8 and P of 9, 8 and Q 2, 4. So those are 2 points. Use a straight edge, draw a line between. Yeah. Okay, so this gives us a chance to not only answer the question, but also let me show you how we sketch a graph. A lot of times you'll hear me say, sketch the graph. And sometimes I get like some sketches from like art class, and that is not what I'm talking about. When I say sketch a graph, I mean you draw the X and Y axis. A lot of times in 8th grade and beyond, we draw all 4 quadrants, but this is all positive, so we'll focus right here in quadrant 1. And 9, 8 is our first point. So I'm going to make 9 ticks on the x-axis because this is our x, right? This is our y. That's x, that's y. Let's just get that out of the way. So I'm going to make 9 ticks over 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 right there. And I'm going to go 8 ticks up. 1, 2, 3, 4, 5, 6, 7, 8. There's my 8. All right. So now where's the 0.98? The 0.98 is over 9 and up 8, right about here. Notice I didn't actually draw my lines like that. I'm just trying to get a general idea. And then I put P, and then I put the coordinate. All right. So that should be good. The sketch gives us a general picture. Now 2, 4, going to go over 2 and up 4. 1, 2, 3, 4. And if we really need to be precise, we could always use a piece of graph paper. But as long as I try to evenly space my intervals, then I'm usually in good shape. So Q is 2, 4. Okay, so our segment is oblique. This is called oblique. Okay, oblique is as opposed to vertical, which is like this, up and down, or horizontal. So we have oblique, vertical, horizontal. If we had a vertical segment, then how we could find the length of that. Like if, let's say our vertical segment was 1, 5, and 1, 2. Then this segment would be, you notice with a vertical segment, your x's are the same, so you can find the length of it by just subtracting the y's. So I would just do 5 minus 2 equals 3. So the length of this segment is 3. Horizontal works the other way. if I had a horizontal segment, let's say 10, 7, and 21, 7. Just picking random numbers, but notice this time with horizontal segments, my y value is the same. And you might look weird off of a graph here, but when I actually make my vertical and horizontal here on this graph, you might be able to see it easier. But at least let's all circle the x's in the vertical and note that they're the same. We can write x's are same and subtract the y's. Subtract y's. X's are the same. And with the horizontal, guess what? We're going to subtract the x's. The y's are the same. Notice how the y's are the same, right? So to find the length of the horizontal segment, you would have to subtract 21 minus 10, which is 11. So this segment is 11 units long. Okay, so that's a little bit about vertical and horizontal segments. It's really good if you have that in your notes. Because, I mean, I hope you felt like even though there's a lot to say, it's really not that hard. You just find the numbers that are different and subtract them. 5 minus 2 is 3. 21 minus 10 is 11, right? But with this oblique segment, nothing is the same. 2, 4, 9, 8. So how do we find the length of an oblique segment? Goodness gracious. Not easy, right? Until today. Because today I will show you. Today we can turn this oblique segment into this here. A right triangle, which we have been studying for the past 3 weeks. And then we have a vertical segment and we have a horizontal segment. And let me just go ahead and give this, how about R? Let's call it R. So the question is, what are the coordinates of R? Well, if you look, R is straight down from P. So it doesn't go left or right of this guy, which means if P has an X value of 9, I mean, if you look at it, R also has an X value of 9. And that does hold true. Look, the vertical, they have the same X value, and PR is a vertical segment. QR is a horizontal segment. What's the same in the horizontal? The Y's are the same. So 4 is over here. And you'll notice this is the point 9, 4. If you look at it, 9, 4. So it's the point 9, 4. In case you didn't know, you can look at your sketch and figure it out that way too. So it's the point 9, 4. I don't know why I have this point over here. It's kind of messing me up. All right, so we have 9, 4 there. Now, the question is, what is the length of this oblique segment? And in order to figure that out, we'll need to use the Pythagorean theorem. And we can easily find the length of the base here using our horizontal idea, subtract the x's. So 9 minus 2 equals 7, so that's 7. And vertical, I'm going to subtract the y's. So that's 8 minus 4. 8 minus 4 is 4. And then we need to use the Pythagorean theorem. A squared plus b squared equals c squared. We know we have our a is 7, our b is 4. So 7 squared plus 4 squared equals c squared. 49 plus 16. And that would be 5965. Of course, we're going to take the square root of both sides. So C is approximately, well, actually, C is exactly equal to the square root of 65. And remembering, let me just, this is a thought bubble. The square root of 64, let me give myself some hair in my there, because I don't have hair. So. Okay, the square root of 64 is 8. So the square root of 65 is going to be approximately 8.1, right? Just a little bit more than 64. All right, so you have that, the square root, yeah, 8. So anyway, so that means that this segment is about 8.1 units long. All right, you think we should do one more like that? Think so. Okay. So one more. Here we go. Use the Pythagorean theorem to find the distance between 2 points on the coordinate. We can do that in coordinate grid: -4, -1, and 5, -8. So this is important because we got integers. All right, so let's do it. G is -4, -1. Okay. Example 2. G is -4, -1, and H is 5, -8. All right. And so we are going to draw our right triangle by sketching a graph. Okay, so I got to go left 4, 1, 2, 3, 4, and down 1. And that's where G is. And H is at 5, -8. 1, 2, 3, 4, 5, over 5 and down 8. So 2, 3, 4, 5, 6, 7, 8. So over 5, down 8. That makes H way down there. And remember, I always just write the coordinate. Helps me do the math. Okay, now I'm going to draw my segment. And now you could draw a right triangle down here, or you can draw a right triangle where I'm going to draw it up here. And GHK, maybe we can use K. All right, so I know it's going to be an X value of 5 and a Y value of -1, just looking at these guys as well as where it is. And then I'm going to subtract the, now this, we need to do a little bit of an integer refresher here. Integer refresh. We have different things. So if both are negative, what do? We add absolute values. And the answer is negative. That's the first rule. Second rule is if one is positive, what do? We subtract absolute values and use bigger sign. Bigger number sign. Bigger value sign, I should say. Okay, and the third rule, 2 negatives in a row equal a positive. You know about that? Okay, so let's put examples here. So an example for number 1. -7 minus 10 is -17. 2 negatives, -7 and negative 10. So 7 plus 10 is 17. So negative 7 and negative 10 is negative 17. Here's an example where it's positive. Okay, let's do 7 minus 10. These are my examples. 7 minus 10. Now we have a negative 10 and we have a positive 7. So in my head, I'm going to do 10 minus 7, which is 3, right? But 7 minus 10, the bigger number is a negative number, the bigger value, absolute value, 10, right? Has a negative sign on it. So 7 minus 10 is negative 3. And one example of two negatives in a row, like this, 7 minus a negative 10. Two negatives in a row become a plus sign, plus plus, and so it ends up being 17, 7 plus 10. So don't worry, we're going to be doing a lot of that. In fact, we're going to do some right now. So here I have to subtract my y values. So I have negative 1 minus negative 8, right? So what do we do with that? Well, first of all, we have two negatives in a row, which make a plus sign. So I'm just going to write negative 1 plus 8. That's rule number 3. Secondly, I have a negative number and a positive number. So I'm going to use rule number 2. Where 1 is positive, I subtract the absolute values. So 8 minus 1 is 7. Okay? And the bigger number is positive, so that is a 7. Now the horizontal numbers. And so I have the y value. So 5 minus negative 4. 5 minus negative 4. And again, I can use rule number 3. Two negatives in a row make a plus sign. Okay, 5 minus negative 4 becomes 5 plus 4, which is 9. So this is 9. So now I have 9 for my horizontal and 7 for my vertical. So I'm going to use the Pythagorean theorem now. A squared plus b squared equals c squared. 9 squared plus 7 squared equals c squared. The nice thing with this section is we're always solving for c. Not too bad. 81 and 49. Always do side math over to the side. 9 to 130. C squared equals 130. Square root both sides. And what is that? 130 is in between 121 and 144. It's like 9 away, 14 away. So maybe 11.4. 11.4. Okay. Well, that's a lot of good stuff there. But now, before we leave our video, we need to go all the way back to section 1 of chapter 4. All right, if you need to take a quick little break, just pause the video. Just pause the video. I'm not going to take a break, but I will understand if you can, if you need to. All right, so I'm gonna go ahead and start a new page for lesson 1. This is 4.1. Develop angle relationships in triangles. Okay, 4 triangles. Okay, and this is 4.1. What is this for? Oh, yeah. And this is for a chapter on angle relation. Angle relationships. All right, not the best handwriting, but it'll do. So we have to do this one because we have a lot of vocabulary. So I'm gonna pause the video and write down my vocab. I'll be back. Okay, so let's talk about this. So the cool thing about this second section we're doing right now is that it kind of builds. We talk about interior angles, angles inside a triangle, the triangle sum theorem. Let's put a star by this one. It's so important. It's gonna have it's gonna get us a lot of places. 3 interior angles of a triangle sum to 180 degrees. The 3 angles inside a triangle add up to 180 degrees. Exterior angles of a polygon formed by one adjacent side of a polygon and extending one side. So you see this triangle here, draw that one, and we're going to extend one side, and now we have this is called an exterior angle. That guy right there. And the last thing, remote interior angles are 2 non-adjacent interior angles to an exterior angle. So these 2 guys are called remote interior. A lot of fancy language for just basic things, angles. So guess what happens? We have some angle relationships here. The first thing to notice is that, let's just write down a straight line. Do you know what the measurement of a straight line? A straight line is 180 degrees. Sorry, a straight line is 180 degrees. So you see how we have a straight line right here? This whole angle from one side, if I make like a half circle, that's 180 degrees. So the question is, what is the measure of this exterior angle? Well, if we don't know it, we can call it x, right? But if we know that the straight line is 180, then we could say 25, this angle, this interior angle of the triangle, and x, if you add them together, you would get 180. Now we have a one-step equation to solve. So let's solve it. So that would mean x equals 155 degrees. And guess what? The 2 remote interior angles, 65 and 90, if you add those together, what do you think you get? You get 155 degrees. So our theorem is our remote interior angles add to the exterior angle. Okay? And we can use that to even set up an equation. If you look in number 3, a machinist is drawing a triangular piece of an industrial machine. So we have an exterior angle, and then we have our 2 remote interior angles. And I can draw a picture of that. And see, the thing about it is, triangles are everywhere. So you definitely can find these things out in the world, and we will look for them. Okay, so if I have this, I know that what I just said was the 2 remote interior angles. If you add them together, 80 plus x, it will be the same as if you just have the exterior angle. So I can set up an equation. 80 plus x, the 2 remote interior, add up to equal the exterior. Craziness, okay? And then what we want to do is we want to get the x's on their own side. So I could take away x from both sides. And then I would have x plus 45. And then I would just take away 45 from both sides. And I would get that x equals 35. So x equals 35. Oh, and that is the measure of the unknown remote interior. And if I want to know the measure of the exterior, I can just add them together, which is 115. Or, yeah, that's what I can do. It's 115. Or you could also substitute in x if you wanted to, and you get 70 plus 45, which again is 115. All right, so that's probably a lot, but that's what we got to do. And then so you can see some of the other questions just have you find the third measure of a triangle. So, they all add up to 180. What we better do, this would be the last one. Let's do it. Okay, so let's say we have this triangle here. So our last example. Is this a remote interior angle question or something else? Well, if you look at the theorems, there is no remote exterior angle here, just two interior angles. And actually they're asking you to find the third angle. So that would be the triangle sum theorem. Triangle sum theorem. Three angles add to 180 in a triangle. So what am I going to do? I'm going to say 31.5 plus 90 plus x equals 180. And I'm going to add these two together, which would be 121.5 plus x equals 180. And then I'm just going to subtract. This is a lot easier than the Pythagorean theorem. Not that that's difficult anymore since we've been doing it so much. And so I'm just going to do some simple subtraction. 68.5. All right. And I think that we have covered everything we need to cover. I will see you in class.